The arc length of a curve from RA to RT is given by this formula. This is just arc length formula, but now it depends on this time, the ending time. So it's a function of t. So that's the first point to make. It is a function of t. Secondly, it is increasing function. This is pretty intuitive because when the t is increasing, certainly the length traveled will be increasing, strictly increasing. So therefore it is increasing function. Another point to make is when it is increasing function, you certainly know that it must be 1-to-1, right? Because so if a function is increasing, for instance, if you imagine a function is strictly increasing, it will not go flat, it will not decrease. So therefore it must be 1-to-1. It passes horizontal line test. Okay, so that's another point to make. Another thing that we also look at is the ds dt, the derivative of this arc length with respect to t. It is equal to the absolute value of vt, and this is basically coming from the fundamental theorem of calculus. So let's quickly review that right here. This is the fundamental theorem of calculus right here. So it says this is the area function. Basically it is, say suppose this is a, this is f of t, right? So now if the ending point is x, this area depends on x. So this integral represents the area from a to t under the curve f of t. So the fundamental theorem of calculus says when you take the derivative, the result is you recover the function being integrated. So I wanna color code it so that you know that this is the variable. So at the end we should have f of x, right? So keep this in mind when we look at the derivative of s. So now when we find the derivative of s, so basically we are finding the derivative of this integral with respect to t. So t is your variable. According to the fundamental theorem of calculus we just reviewed, so it will recover the function being integrated. So therefore it will be equal to the function being integrated is this guy, right? So v, length of v, of course the variable is given in the upper limit, so it will be t. So this is another point to make. That's why ds dt is just this function. Obviously this is a speed, absolute value of velocity, or the magnitude of velocity is just speed. Speed is greater than 0, so which means this is also increasing. Now so because it is 1-to-1 function, because when it is increasing function, that means it has to be 1-to-1. So we can actually solve for let me zoom out a little bit here. So therefore we may solve for t as a function of s. This can be done when you have 1-to-1 function. You can solve. So now we have s of t, right? So and then this function, because it's 1-to-1, you can find its inverse function. In other words, you can solve for t in terms of s. This actually is its inverse, all right? Inverse. So if you do that, the curve RT now can be reparameterized in terms of s by doing this substitution. I'm going to demonstrate this in problem number 5. Before we do that, another point to make is if the magnitude of velocity is equal to 1. In other words, this guy is 1. So this and this definite integral will be equal to t minus a, right? So in this case, s of t is equal to t minus a. Now let's think about this. What does this really mean to us? That means if time is if for every unit change in time, there will be every unit change in your arc length. So if you have 2 unit change in time, you must have 2 unit change in s. Okay, so which means the parameter t is now corresponding to arc length, or t is equal to s plus a. So that this is the terminology that we use to describe what we see here when this is 1, when the speed is 1. So in other words, let's repeat one more time. When you hear parameter t corresponds to arc length, that means for every unit time t change, there will be 1 unit arc length change. Now, when this happened, RT should be equal to R of S plus A because of this, right? S equals T minus A, which means T equals S plus A. When you substitute this into the function, that's R of S plus A. You see that originally the function is the parameter is T, now the parameter is S. So when you do this change, the function is now parameterized in terms of S. Now when, actually to be precise, it's now reparameterized correspond to S, because for every unit change in T, there's only one same unit change in arc length. Now so this is the quick some kind of talking through the formula in detail, or some important notes to make. In my next video, I'm gonna explain that how we're gonna reparameterize a function R in terms of S.